There are breakthroughs happening all year, not just in the biological field, but in how we use biological data. NASA spaceflight experiments have generated millions of data points from how cells grow, divide, and react to microgravity and radiation. But this data sits across thousands of papers and databases, so complex that most clinical researchers will never see it. What if we could make all that data accessible, connected, and useful for understanding human disease? That's what SpacePath does. It linked spaceflight biology with clinical research, turning NASA's hidden data into a new lens for drug discovery. Every new drug therapy starts with the same question: which switch could we flip to stop the disease? And in recent years, it has been increasingly important. Just one database, as you can see at the right down side, generates over 100,000 data entries. So these we will need to connect. The results, months are lost if researchers have to do it manually. And when it's cancer, every delay costs billions in R&D and even lives. A bioinformatics dashboard is what we will have, SpacePath. It links space research to terrestrial research and clinical studies. Think of it as Google Maps for disease biology, where every protein pathway clinical trial is connected via one visual map.
We have built Protein Lens, keeping in mind how we can utilize the NASA space biology data, combine it with already present clinical trials and the pathways which are provided by KEGG. To start with, let's try to ask our system something related to a protein called TNF. What happens to TNF in microgravity? In the backend, we first identify which protein we are talking about, which is TNF. We list down all the details about the protein. Once we have got this thing, we retrieve most useful information from the 600 publications we have provided by NASA space biology data. So here you can see we have provided the protein information, which involves alternate names of the protein, gene synonyms, and the biological functions. Bottom down, we have a research summary, which highlights how TNF is affected in microgravity and all the relevant research papers which the user can go ahead and check out. So here we provide a link and it points out to the PubMed Central, where the user can go ahead and read the research paper. On the right, we have three different tabs. One is Pathways. Pathways provides we retrieve the pathways of that particular protein and show it in a more visual way. So user can go ahead and look at all the details of that pathway. Second, we have clinical trials. We list down all the clinical trials, starting with the latest publications. So here you can see we have listed down a few of the clinical trials. The user can read a brief summary, and if he wants to go deeper into it, he can go ahead and visit the web page. The third part of our framework is interactive framework, which relates all the information which we showed and tries to take out meaningful insights from it. To start with, we have the input protein. We show how it is related to clinical trials as well as NASA papers. The darker line shows strong correlation between those nodes. On the right, we show confidence level. We show that how NASA research is related to the clinical trial research which has been done on Earth. Coming back to the presentation.
First, the user query processing blocks uses GPT-4o to interpret what the user is asking. For example, EGFR and microgravity. It defines key entities like proteins, diseases, and conditions. Next, in the literature retrieval stage, we use SBioBERT embeddings and MS Macro Cross Encoder re-ranker-to to find the most relevant NASA publications. Then MET-LAMA2 or GPT-4o summarizes the evidence. Third, the clinical trials lookup model connects to the clinical trials government API, filters trials related to that same protein or condition, and extracts IDs, phases, and outcomes, summarized again by MET-LAMA2. Fourth, the pathway exploration module uses the KEGG API to fetch the top 25 pathways and visualizes molecular interactions. Finally, the knowledge graph and confidence panel built on HTML, BizNetwork, and Chart.js integrates everything. It shows how NASA and clinical evidence connects across proteins, pathways, and trials, ranked by confidence. And that is SpacePath, turning spaceflight biology into a new engine for human health discovery. Thank you, and we can't wait to see what new therapies the next discovery in orbit might inspire.
Thank you.